we want to write it in rectangular form. That we use to here is z is equal to 7 times the cosine of 60 degrees plus 1 I times the sine of 60 degrees. Well, usually I like to start by drawing a triangle. It doesn't have to be a scale. It just had to help me see what's going on now. Rewritten in complex or polar complex form, z is equal to r times the cosine of the theta plus I times the sine of theta. This distance is the r and this distance is theta. This distance is y, in this distance is x. Well, I have my r value. R is 7, so this is a 7, and I have my theta value, that is 60, so this is 60 degrees. Now using the sine function, remember that sine of our angle is equal to the opposite over the hypotenuse. This is the right triangle, so the sine of theta, which is 60 degrees, is equal to the opposite side, which is y over the, which is 7, so y is equal 7 sine 60, and this is equal to the approximately 6.06 for my x value. Well, I know the cosine of theta is equal to the side length over the, so the cosine of 60 degrees is equal to x over 7. So x is equal to 7 times the cosine of 60 degrees. And well, we will find that x is equal to the 3.5. So I have my x and my y value. But remember, this is not normally x and y. This is actually the real and the imaginary axis. So that means z is equal to 3.5 plus 6.066i. Because remember, complex number in rectangular form looks like z is equal to x plus y I or plus bi. Here our x is 3.5 or our a is 3.5 and our or y or p values is 6.06. Just do not forget to include our I for the p or the